Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So I personally created this playlist in order for those who are planning to take up engineering. We'll have this channel which is complete, so that's why it's called one-stop channel for your preparations to engineering life. I hope that my videos are helpful to your preparations.
So let's have second solution by elimination method. So we plan to eliminate MA first. So to do that, let's multiply equation 1. We plan to eliminate MA. So we multiply equation 1 by 332.5 divided by 264. So multiply everything, equation 1 by 332.5 divided by 264. So this becomes 2544 times 332.5 over 264. So that's 35,245 over 11 AX. Then 2508 times 332.5 divided by 264, 3,158.75 AY. Then plus 332.5 MA. Then 106,380 times 332.5 divided by 264 is 133,982.386. So let's call that equation 1.1. Then we subtract equation 2. So let's simplify. This is equation 3.1, by the way. After we multiply equation 3 here by 332.5 over 35. So the coefficient of MA in equation 3. So the first term becomes 264 times 332.5 over 35, 2508 AX. The second term is 332.5 times 332.5 over 35, 3158.75 AY. And the third term is 332.5 MA. So 16,470 times 332.5 over 35 is 156,465. So we can now eliminate MA from these equations here. So by subtracting equation 3.1 from equation 1.1. So 35245 over 11 minus 2508 is 7657 over 11 AX. Then we can eliminate, by the way, AY and MA simultaneously. So luckily we can eliminate these two terms. So from here, 133,982.386 minus 156,465 is negative 22,482.614. So to solve for AX, negative 22,482.614 times 11 divided by 7657. So AX is negative 32.298, which is very close to our answer before, which is negative 32.299 kilonewtons. So that's okay. Then we substitute the value of AX into equation 1. So 2544 times negative 32.298 plus 2508 AY plus 264 MA equals 106380. Then we have a new equation for equation 1. 2508 AY plus 264 MA equals 188.546. 188,546.112. Call that equation 1A. Then equation 2, 2508 times negative 32.298 plus 13,640 over 3AY plus 32.5 MA equals 263,137.5. This is equation 2. Then we substitute the value of AX. So equation 2 becomes 13,640 over 3AY plus 32.5 MA equals 344,140.884. So call this equation 2A. Then we multiply equation 1A by 332.5 divided by 200 64 so that we can eliminate MA. So 2508 times 332.5 over 264 becomes 3158.75 AY plus 332.5 MA equals 188,546.112 times 332.5 over 264. So that will be 237,468.115. So we can now eliminate MA from these equations 2A and equation 1.AA by subtracting equation 1.AA from equation 2A. So we can solve AY. So 13,643 over 3AY minus 3158.75 AY is 16667 over 12 AY. Then 344140.884 minus 237,468.115 is 106,672.769. So AY therefore is 12 times 106,672.769 over 16,667. So AY can now be solved 76.803 kilonewtons. Then substitute into equation 1A. So 2508 times 76.803 plus 264 MA equals 188,546.112. So we can solve MA 188,546.112 minus 2508 times 76.803. Then the result divided by 264. So that is MA. So MA is negative 15.49 kilonewton meter. So there's a very small difference to our previous answers, and that is acceptable because the method is different and we have new rounded off values or new decimal values here, as long as the answers are very close, so that's acceptable. So AX negative 32.298 for this method. AY is 76.803, which is, I think, the same. MA is negative 15.439 kilonewton meter. So the answer before was negative 15.42, and if rounded off or comparing, that's very, very close. So that's it for this method by elimination. There are other methods like using matrix, using matrix inversion, and other methods, Cranier's rule, whatsoever, but these two methods are methods that can be remembered because these are basic methods, substitution and elimination method. If you want to solve this by those other methods, advanced methods, then you can do so as long as you will arrive at the same answers. Next topic, let's have quadratic equations and the quadratic formula. So let's have a brief review of these equations, important equations, because you will definitely encounter these equations in statics. So ax squared plus bx plus c equals 0. That's the general quadratic equation. Then to derive the quadratic formula, let's complete the square in x. So divide everything by a first. So we have x squared plus b over a, then b over a x, then equals negative c over a. So x squared plus b over ax equals negative c over a. Let's complete the square in x. To complete the square in x, remember, we have to add the square of 1/2 of the coefficient of x. Half of the coefficient of x is b over 2a, then you have to square that. So it becomes x squared plus b over ax plus quantity b over 2a squared equals negative c over a plus b over 2a quantity squared. So whatever is added in the left side, that should also be added in the right side. Remember the axiom of equality. Whatever is added in the left side, you also add in the right side. So this is now a perfect square trinomial whose factored form would be square root of x squared, which is x, then square root of b over 2a, which is b over 2a. Square root of b over 2a quantity squared is b over 2a. So this is quantity x plus b over 2a quantity squared, then equals, so if we simplify the right side, that would be negative c over a plus b squared over 4a squared. So x plus b over 2a quantity squared equals b squared minus 4ac over 4a squared, because the LCD is 4a squared. 4a squared divided by 4a squared is b squared, so we write the positive term first in the right side. Then 4a squared divided by a is 4a, then times negative c, so negative 4ac, all over the LCD, which is 4a squared. Then extract the square root, x plus b over 2a equals plus minus square root of b squared minus 4ac all over 2a. Then move this term to the right, so x is negative b over 2a plus minus square root of b squared minus 4ac over 2a. So the roots are, so x negative b plus minus square root of b squared minus 4ac over 2a. So the roots are negative b plus square root of b squared minus 4ac all over 2a. And the second root is negative b minus square root of b squared minus 4ac over 2a. So those are the roots. So the discriminant of the quadratic equation is the term b squared minus 4ac. So that's the discriminant of the quadratic equation. Then if b squared minus 4ac is 0, the quadratic equation is a perfect square trinomial. So that is, the roots are repeated. There's only one root that is repeated. So for example, if you have x squared minus 4x plus 4, this is a perfect square trinomial because the square root, because twice the square root of x and 4 is 4x, though the sign here is negative, so in factored form that would be x minus 2 quantity square. So the root is 2, and there are two multiplicities of the root. So we have 2 and another root is 2. So that is repeated. That's the meaning of a perfect square trinomial. So a perfect square trinomial is such that the middle term is twice the square root of the first and the second. So it is plus minus. Another example is 9x squared plus 24x plus 16. So square root of 9x squared is 3x, square root of 16 is 4, 3x times 4 is 12, times 2 is 24x, so this is the middle term. Therefore, writing this in factored form is square root of 9x squared is 3x, square root of 16 is 4. Since the sign at the middle is positive, so the sign dividing, that sign separating these two terms is also positive. So the root is, equate this to 0, is negative 4/3, so twice. So one root is negative 4/3, the other root is also negative 4/3. That's the meaning of that. Then the nature of roots, if b squared minus, roots are distinct when b squared minus 4ac are greater than 0. So that is, if the discriminant is positive, then we have two distinct roots. Obviously, it is obvious in these two roots here. If b squared minus 4ac is positive, so definitely the roots are distinct. And when b squared minus 4ac is equal to 0, the roots are repeated. So it is a perfect square trinomial, or equal. Then third, roots are complex conjugates when b squared minus 4ac is less than 0, or when the discriminant is negative. So when the discriminant is negative, the roots are complex conjugates. So if one root is a plus square root of b times I, the other root is definitely a minus square root of b times I. Or it may be a plus bi or a minus bi. Those are the roots when the discriminant is negative or less than 0. So the number of positive roots, real roots, is equal to the number of variations in signs of the discriminant of a, which is ax squared plus bx plus c. The number of negative real roots is equal to the number of variations in signs of the terms of a times negative x squared plus b times negative x plus c. So in other words, for the number of negative roots, you just replace x by negative x. Although this is no longer important because for a quadratic equation, there are expected two roots, and they may be all positive, they may be all complex conjugates, so there's no real root, or it may be one positive root, the other is negative root. If there are two negative roots, then there's no positive root because the number of roots is already 2. And we expect only 2 roots. So for example, find the roots of 6x squared plus 5x minus 6 equals 0. So if we look at the signs plus, plus, minus, so there's only one variation in sign. So meaning there's only one positive real root. Because there, we expect two roots, two real roots, then the other root is definitely negative. Now what if there's no variation in sign in x here? So for example, 6x squared plus 5x plus 6. If that is the situation, then there's no variation in signs. The probability is there will be no real root. And because this is always positive, even if we replace x by negative x, and this becomes negative, and this is also negative. Therefore, if this is positive, this is only the negative root. So it's impossible that there is one negative root if there's no way that this is there is a positive root. So again, because there is only one variation in sign in x, plus plus minus, so we expect one positive root. There's no need to check the number of negative roots because it is also obviously 1. So even if we change this to negative x, this is still positive 6x squared. This is negative 5x, this is negative 6. So there is also one variation in root from positive to negative. Then because the next is negative, so one variation in sign when x is replaced by negative x. So there's also one negative root. So that's the expectation, one positive root and one negative root. So let's now prove it by first dividing everything by 6. Let's use this completing square method. B squared minus 4ac is 5 squared minus 4 times 6 times negative 6. This is greater than 0. In particular, the discriminant is 169. So that's why we have distinct roots, meaning to say different real roots. That's the expected roots. So by completing square and dividing everything by 6 first, so we have x squared plus 5 over 6x, then negative 6 over 6 is minus 1. Then let's complete the square in x. So take note that the missing term to make it a perfect square trinomial is 1/2 of 5 6 or 5 over 12 quantity square. So that's why we added 25 over 144. 5 over 12 quantity square is 25 over 144. Then after we move negative 1 to the right, it becomes positive 1. Since we added 25 over 144, we also add 25 over 144 to the right side of the equation. So this is now a perfect square trinomial. This is written as x plus 5 over 12 quantity square. And this is 169 over 144 at the right side. So by extracting square root, so we have x plus 5 over 12 equals plus minus 13 over 12. Square root of 169 over 12, 144 is plus minus 13 over 12. So x plus 5 over 12 is plus minus 13 over 12. If we use plus, 13 over 12 minus 5 over 12 is 8 over 12 or 2/3. So one root is 2/3. If you use minus, negative 13 over 12 minus 5 over 12 is negative 18 over 12, or that is negative 3/2 or negative 1.5. So the roots are 2/3 and negative 1.5 or negative 3/2. So another way is you use this quadratic formula. So take note that the square root of the discriminant is 13. So b is 5. So negative of 5 plus 13 is 8 divided by 2 times a, which is 6. 2 times 6 is 12. So 8 over 12 is 2/3. Then the other root, negative 5 minus 13, negative 18 divided by 12. Negative 18 over 12 is negative 3/2. So that's the other way of getting the roots of that quadratic equation. So let's proceed to geometric requirements. One is the sum of the interior angles of a triangle. Let's prove it. Let's call this angle theta 1, this one theta 2, then this angle third here is theta 3. So we draw a line parallel to the base. So we also extend this side and a line from this corner here parallel to the base. So this side is like a line that intersects two parallel lines, and therefore the angles it forms with these parallel lines will be equal. So if this is theta 2, that is also theta 2. Again, if this is theta 2, that's also theta 2 because this is parallel to this side and we have a common side also. So that's why this is theta 2. And since this is the extension of this side here, and this line is parallel to this base, then this angle here is also the angle between this extension of that side and this line which is parallel to this. So that's theta 1. So obviously, theta 1, theta 2, theta 3, the sum is a straight angle, and a straight angle is 180 degrees. Therefore, the sum of the interior angles of a triangle is 180 degrees. So theta 1 plus theta 2 plus theta 3 is 180 degrees. Then, if we drop a line perpendicular to the base, so that's theta 1, theta 2, and that is theta 3 supposedly. So if we drop a line perpendicular to the base, then we form two right triangles. Therefore, the measure of this angle here is 90 degrees minus theta 1, while this angle here is 90 degrees minus theta 2. Since theta 3 is expected to be 180 degrees minus the quantity theta 1 plus theta 2, quantity theta 1 plus theta 2, then we add these angles, 90 degrees minus theta 1 and 90 degrees minus theta 2, and equate it to theta 3. So we get the same answer, that is theta 3 equals 180 degrees minus quantity theta 1 plus theta 2 as expected. Then we have sum of interior angles of a closed convex polygon. By the way, a convex polygon is one in which when two sides are extended will not cross the polygon. That's a convex polygon. If any two sides are extended and will cross the polygon, then it is called concave polygon. So we will denote the interior angles as theta 1, theta 2, theta 3, theta 4, theta 5 up to theta n. Let's imagine that there are n sides, n corners, and therefore n interior angles. So the analysis is for a triangle, the sum is 180 degrees. So let's draw the number of non-overlapping triangles for four corners or four sides. So for four sides, we can only draw two non-overlapping triangles. So again, for four sides, we can draw two non-overlapping triangles. This is the first and that's the second. Or you may cancel this and write this diagonal here, dividing line here. So we also have two non-overlapping triangles for four corners. So for three corners, only one. For four corners, two. For five corners, three. So 1, 2, 3. For 5 corners, 3, and 3 is 5 minus 2. For 4 corners, 2, and 2 is 4 minus 2. So if there are n corners, therefore the number of non-overlapping triangles is in general n minus 2. So the number of non-overlapping triangles that can be drawn from a closed convex polygon is n minus 2. Since the sum of the interior angles is 180 degrees, therefore the sum of these interior angles is n minus 2 times 180 degrees. So we have this formula for sum of interior angles, n minus 2, quantity n minus 2 times 180 degrees. Again, n minus 2 is the number of non-overlapping triangles that can be drawn from n-cornered closed convex polygon. And since each triangle has a sum of its interior angles 180, therefore the sum of interior angles of a closed convex polygon is in general n minus 2 times 180 degrees. For a regular polygon, its interior angle is n minus 2 times 180 degrees divided by n. So if we denote the interior angle as theta, then the total interior angles would be n times theta because the polygon is regular. And we equate that to the sum of interior angles of a closed polygon, closed convex polygon, n minus 2 times 180 degrees. Therefore, the measure of each interior angle of a regular polygon is n minus 2 times quantity 180 degrees, or quantity n minus 2 times 180 degrees divided by n. So for example, for the interior angle of a regular dodecagon, it is equal to dodecagon 12 sides, 12 corners. So theta is equal to 12 minus 2 times 180 degrees divided by 12. So that would be 150 degrees for that case. Okay, let's have next the properties of a parallelogram. So a parallelogram is a quadrilateral having its two opposite sides equal and parallel. So this is it. So these are the facts or properties. Opposite angles are equal and adjacent angles are supplementary. So if this is theta, that's also theta there. And if we draw a horizontal line, the extension of this base here, this is also theta. The measure is also theta. So this is 180 degrees minus theta, and the opposite is 180 degrees minus theta. So that is opposite angles are equal, then adjacent angles are supplementary, or the sum of the adjacent angles is 180 degrees. That's what we mean by supplementary angles. Then the diagonals bisect each other at their point of intersection. So this is half of this first diagonal to the intersection, also half of this diagonal, this entire diagonal from the intersection. So if we denote the one angle of intersection as alpha, then this is also alpha here. So this is beta, and this is also beta. And take note that alpha plus beta is equal to 180, or alpha and beta are supplementary angles again. So beta is 180 degrees minus alpha. Then right triangle basic trigonometric functions. So this is the acronym that you should remember, SOHCAHTOA. I hope that you're familiar with that. So the meaning of SOH is sine of any angle in a right triangle only is equal to the opposite side divided by hypotenuse. So the hypotenuse is the longest side of a right triangle. So if this is theta, this is the opposite side. So this is 90 degrees minus theta, the complement of theta. The sum of complementary angles is 90 degrees, or when two angles is equal to 90 degrees, then each angle is called the complement of the other. So this is co-theta. This is the opposite side, denote that by B. This is the adjacent side, which is denoted by A, and this is the hypotenuse. Let's call that C. So sine of theta is equals opposite side over adjacent side, in particular B over opposite side over hypotenuse, in particular B over C. Then cosine of theta is adjacent over the hypotenuse, ca. Then it is equal to A over C. Then tangent of theta is equal to opposite over adjacent side. So it is equal to B over A. Then we have the reciprocal identities. Reciprocal of sine, or 1 over sine, is called cosecant of theta, which is hypotenuse over opposite side. And so this is equal to C over B. And C over B is hypotenuse over opposite side. So again, cosecant theta is the reciprocal of sine theta, and vice versa. So cosecant theta is 1 over sine theta, and sine theta is 1 over cosecant theta. Then the reciprocal of cosine, or 1 over cosine, is secant of theta, which is hypotenuse over adjacent side. And it is equal to C over A. So secant theta is also 1 over cosine theta, and cosine theta is 1 over secant theta. Then reciprocal of tangent theta is cotangent of theta, which is adjacent side over opposite side, or A over B. And cotangent theta is 1 over tangent theta. Likewise, tangent theta is 1 over cotangent theta. That's it. Then we have right triangle complementary functions. So sine theta is opposite side over the hypotenuse. So therefore, it is also cosine of 90 degrees minus theta, or the other way, cosine of complement of theta. So it's the same. Cosine of theta is adjacent side over the hypotenuse, and therefore it is the sine of quantity 90 degrees minus theta, or sine of complement of theta, because sine of complement of theta is the opposite is the adjacent, opposite to that is adjacent, and the hypotenuse remains the hypotenuse. Then tangent of theta is opposite side over adjacent side, so it is the cotangent of 90 degrees minus theta, or simply cotangent of co theta. Co means complement. Cotangent of theta is opposite adjacent side over opposite side, and it is the tangent of 90 degrees minus theta, or simply tangent of co theta. Then secant of theta is hypotenuse over adjacent, and it is also the cosecant of 90 degrees minus theta, or cosecant of co theta. Finally, cosecant of theta is equal to hypotenuse over opposite side, and it is equal to secant of quantity 90 degrees minus theta, or simply secant of co theta. So that's it for complementary function. Then Pythagoras theorem, which is very important for right triangles only, which states that the sum of the squares of the adjacent side and the opposite sides is the square of the hypotenuse. So that's the statement by Pythagoras theorem. There are many proofs of these Pythagoras theorems, and being a student in engineering, I know that you know that Pythagoras theorem, or you're familiar with that. So that is adjacent side square plus opposite side square equals hypotenuse square. So if we divide everything by hypotenuse square, then the right side becomes 1. And remember that adjacent side over hypotenuse is equal to cosine of theta. Then since this is squared, so cosine squared theta, opposite over hypotenuse is sine of theta, and this is squared, so sine squared theta. Then this becomes 1 because we divide everything by hypotenuse square. So the fundamental trigonometric identities are the following. So we have cosine squared theta plus sine squared theta equals 1, or sine squared theta plus cosine squared theta equals 1. Then if we divide everything by cosine squared theta, then we have, or sine squared theta, we have 1 plus cotangent squared theta equals secant squared theta, cosecant squared theta. Again, divide this by sine squared theta. So sine squared theta over sine squared theta is 1. Cosine squared theta over sine squared theta is cotangent squared theta. And 1 over cosine squared theta is, or sorry, 1 over sine squared theta is cosecant squared theta. If instead we divide everything by cosine squared theta, so this sine square over cosine square is tangent squared theta. This becomes cosine squared theta over cosine squared theta, which is 1. And 1 plus 1 over cosine squared theta is secant squared theta. So the third fundamental identity is tangent squared theta plus 1 equals secant squared theta. So I hope you can remember not all this, even just this one. And remember the definition of sine over cosine as tangent theta, cosine over sine as cotangent theta, 1 over sine theta is cosecant theta, and 1 over cosine is secant theta, so that you can also derive this immediately after you write this identity.